Hello friends, welcome to my lecture on Bayes theorem and probability networks. We know that the conditional probability of A given B is equal to PA intersection B divided by PB. This formula can be put in a different form by using the Bayes theorem. The formula is known as Bayes formula or Bayes theorem. It is known after Thomas Bayes, who actually developed this formula. Now we can write V equal to, if you have the set V A and the set B, then this is A intersection B, and this part is B minus A, this part. Okay. So B can be written as A intersection B union B minus A, which is equal to AB union B intersection A dash. A intersection B, B also write as AB. So B is equal to AB union B intersection A dash, and therefore now AB and B intersection A dash are mutually exclusive. Okay. So since AB intersection B intersection A dash is equal to phi, okay, we have probability of V equal to probability of AB plus probability of B intersection A dash, and now probability of A given B. Probability of A given B is PA intersection B divided by PB. We can write it as PAB equal to, by multiplication theorem, PAB equal to PA into probability of V given A, and probability of B is equal to probability of AB, that is probability of A intersection B plus probability of B intersection A dash. Okay. Or we can put it as probability of A given B is equal to probability of A into probability of B given A, and then probability of AB is equal to probability of A into probability of B given A dash, and probability of B intersection A dash again by multiplication theorem can be written as probability of A dash into probability of B given A dash. Okay. This formula is known as Bayes formula. It relates the probability of A given B with the probability of A, probability of A dash, probability of B given A, and probability of B given A dash. If we partition the sample space S into more than two mutually exclusive, and suppose you have this sample space, let us partition this. Okay. So this is your H1, H2, H3, H4, H5 and so on. Okay. So if we partition the sample space S into, this is your S, into more than two mutually exclusive events H1, H2, Hn, then S is equal to H1 union H2 union H3 and so on union Hn, where Hi intersection Hj is equal to phi. You can see here that H1, H2, H3, H4, H5, they are all mutually exclusive. That means Hi intersection Hj is equal to phi for all I not equal to j. Now if V is any event, then B can be written as B intersection S, because S is the sample space. Okay. And S is equal to union of H1, H2, Hn. So B equal to B intersection H1 union H2 union H3 and so on union Hn. Now using the formula of the set theory, intersection is distributive over union. So we have B intersection H1 union B intersection H2 union B intersection Hn, and since H1, H2, Hn are mutually exclusive, B intersection H1, B intersection H2 and B intersection Hn are also mutually exclusive, and therefore probability of B will be equal to probability of B intersection H1 plus probability of B intersection H2 and so on probability of B intersection H1. But probability of B intersection H, so we can write here. So this implies that probability of B is equal to probability of B intersection H1 plus probability of B intersection H2 and so on probability of B intersection Hn. Okay. Now, we can use multiplication theorem. So, probability of B intersection H1 will be probability of H1 into probability of B intersection H1 plus probability of H2 into probability of B intersection H2 probability of Hn into probability of B intersection Hn. B given Hn, probability of B intersection Hn is probability of Hn into probability of B given Hn. So, this is equal to this right hand sum can be written as sigma I equal to 1 to n P Hi P B given Hi. Then the conditional probability of Hi given B. Okay. The probability of Hi given B is equal to P Hi into P given Hi divided by sigma I equal to 1 to n P Hi P given P of PV P of probability of B given Hi. Okay. So, this is known as Bayes theorem, Bayes formula. Now, Bayes formula is another way of writing the conditional probability formula. Let us consider a problem on this Bayes theorem. An electric signal can be received from a certain source randomly via routes R1, R2 and R3. The probabilities that an error will be introduced on these routes is are 1 by 5, 1 by 4 and 1 by 3 respectively. If the signal arrives with no error in it, okay, then we have to find the probability that it was sent via route R3. So, 1 by 5, 1 by 4, 1 by 3 are the probabilities that error occurs via route R1, via route R2, via route R3. So, probability that no error is introduced via route R1 will be equal to 1 minus 1 by 5, that is equal to 4 by 5. Okay. Similarly, probability that no error is introduced via route R2, this will be equal to 1 minus 1 by 4 equal to 3 by 4. Okay. And similarly, probability that no error is introduced via route R3, this will be equal to 1 minus 1 by 3 equal to 2 by 3. Okay. Now, we want the probability if the signal arrives with no error in it. So, we are given that signal arrives with no error in it, probability that signal arrives with no error will be equal to, now there are 3 routes R1, R2, R3. So, each route has probability 1 by 3. Okay. So, 1 by 3, okay. Let us say we are taking the route R1. So, R1 has route 1 by 3, R1 has the probability 1 by 3 multiplied by no error. So, 4 by 5. Similarly, R2 has the route R2 route has the probability 1 by 3 into the no error in it. In the there is no signal error in the signal via route R2. So, it is 3 by 4, then 1 by 3 the probability that the signal comes via route R3 with no error in it. So, 1 by 3 into 2 by 3. Okay. Then this is the probability that the signal arrives with no error in it. Now, then we need to find the probability that this it was sent by route R3. So, no error via R3 given that signal arrives with no error. Okay. Signal arrives with no error. So, this is probability that there is no error via route R3. So, 1 by 3 into there is no error via route R3. So, 1 by 3 into 2 by 3 divided by 1 by 3 into 4 by 5 plus 1 by 3 into 3 by 4 plus 1 by 3 into 2 by 3. 1 by 3 we can cancel, and then we have 2 by 3 divided by 4 by 5 plus 3 by 4 plus 2 by 3. and this is 2 by 3 divided by here we have LCM 60 and we have 12 into 4, 12 4 ja 48 plus 15 3 ja 45 plus 22 ja 40. Okay. So, this comes out to be 2 by 3 into 60 over 133. Okay. That means 40 over 133. Okay. So, this is the answer. Okay. 40 over 133. The probability that the signal was sent via route R3 with no error in it. Now, let us go to second question. An executive is in a hurry to reach the airport to catch the flight scheduled at 6 am. Unfortunately, his car was under repair and he had to catch a taxi to reach the aerodrome. The probability of getting a taxi at such an early hour is only 0.23. Okay. So, suppose let us say A denote the event that the executive gets the taxi. Okay. So, probability of A is equal to 0.23. Okay. If he gets the taxi, he would catch the flight with probability 0.85. Okay. So, let us say he catches the executive catches the flight. Executive catches the flight okay, given that he got the taxi. Okay, probably the executive catches the flight, this is 0.85. Okay, so this is if given that he gets the taxi. So, this is probability of B given A. Okay. This is probability of B given A, where B is the event that he gets the flight. Okay. So, B is the where B is the event that the executive catches the flight. Okay. So, probability that the executive catches the flight given that he gets the taxi is probability of V given A, which is 0.85. If he is unable to find a taxi, he would catch the flight with 0.43 probability by resorting to some other means. Okay. So, here let us say then he gets the probability 0.43 probability that he does not get the taxi. Okay. So, probability of B given A dash is equal to 0.43. Okay. He catches the flight, when he does not get the taxi, he resorted to some other means. So, probability of B given A dash is 0.43. In such a situation, what is the probability that the executive will catch the flight? So, probability of B. Okay. Probability B is the event that the executive catches the flight. Okay. So, probability of B is equal to probability of A into probability of B given A plus probability of A dash into probability of B given A dash. Okay. So, probability of A is equal to 0.23 into probability of B given A is 0.85 plus probability of A dash. Probability of A dash is equal to 1 minus 0.23. Okay. Probability of A dash is 1 minus 0.23 into probability of B given A dash, which is 0.43. Okay. So, this is equal to 0.23 into 0.85 plus 0.77 into 0.43. Okay. So, that is the probability. Okay. 0.23 into 0.85 plus 0.77 into 0.43. Okay. That is the probability that the executive catches the flight. Now, if he catches the flight, what is the probability that he went to the airport in a taxi? Okay. So, let us find this. If he catches the flight, so we are given that he catches the flight. Now, we have to simply find the probability that he went to the airport in a taxi. Okay. So, we have to find the probability that he catches the flight. It is given, he catches the flight and he went to the airport by taxi. Okay. So, let us see P A into P B by A. P A is the probability, A denotes the event that he gets the taxi, and P B by A is the probability that he catches the flight given that he gets the taxi. Okay. So, and the probability that he catches the flight is 0.23 into 0.5 plus 0.77 into 0.43. Okay. So, we have to find the probability went to the airport by taxi. So, P A into P B by A divided by he went to the airport by taxi, that is P B. Okay. P B is P A into P B by A plus P A dash into P B by A dash. Okay. He went to the probability that he went to the airport by taxi given that he catches the flight. Okay. So, P A is 0.23, okay, and P B by A is 0.85. Okay. 0.23, P A is 0.23, P B by A is 0.85 and divided by P B. P B is 0.23 into 0.85 plus 0.77 into B by A. Probability of B by A is 0.43. Okay. So, this is the required probability. Now, let us go to question number 3. There are 3 machines in an electric plugs manufacturing company. The first machine has the highest capacity, that it produces 45% of the total output during the day. Okay. So, let A denote the event that the first machine has the highest capacity that it produces production by machine A. Okay. So, let A be the event denoting the production by machine A, by machine 1. Okay, by machine, there are 3 machines, machine 1, machine 2, machine 3, okay, by first machine. So, this is, so probability of A then is given by 0.45. Okay. Similarly, let B be the event denoting the production by machine 2. Okay. Then P B is equal to 0.35. Okay. Similarly, let C be the event denoting the production by machine 3. Okay. Then P C is equal to 0.20. Okay. The production of by machine 1 is 0.45, 45%, probability is 0.45. Here the probability for machine 2 is 0.35, for machine 3 it is 0.20. The first machine not only stands first in its capacity of production, but in efficiency also. Only 2% of the output of machine 1 is defective. Okay. So, probability of defective output by machine 1 is equal to 0.02. Okay. Only 2% of the output of machine 1 is defective, 3% of the total production of machine 2 is found to be defective. So, this is let me write okay, this is 2, then we have 3, then we have 4. Okay. So, similarly probability of defective output by machine 2 okay, given A okay, is equal to 0.03, and probability of defective output by machine 3 okay, given C okay, is equal to 0.04. Okay. So, this is probability of defective output by machine 1 given A. Okay. A is the event denoting the production by machine 1. So, this is 0.02, and then probability of defective output by machine 2 given B is equal to 0.03, and probability of defective output by machine 3 given C is equal to 0.04. Now, we have to find during the process of quality control, if the inspector finds a defective item, what is the probability that it has been manufactured by machine 1. Okay. So, probability that the defective item came from machine 1. Okay. So, it is equal to probability of a defective item from machine 1 divided by probability of defective item. Okay. So, probability of A into probability of a defective item given A. Okay, from machine 1. Probability of defective item from machine 1 given A divided by P A into probability of defective item from machine 1 given A. So, we can call them as E F G. Probability of defective item from machine 1 is the event E. Okay. Probability of defective item event, let us say E denotes the defective item from machine E1. Okay. You can say like that, let E be the event that defective item is produced by machine A, machine 1. Similarly, E F be the event that the defective item is produced by machine 2, and G be the event that it is produced by machine 3. Okay. So, then you can write here, we can in short we can write like this: probability of E given A. Okay. Probability of E given A plus probability of B into probability of F given B, and then probability of C into probability of G given C. Okay. So, this will be equal to then P A, this will be equal to 0.45 into 0.02. Okay. 0.45 into 0.02, divided by 0.45 into 0.02, okay, for the first term, then 0.35 into 0.03 plus 0.20, okay, 20%, 0.20 into 0.04. So, this will be equal to we can simplify this 45 into 2, that is 90 divided by 90 plus 105 plus 80. So, we get 90 by 275, which will be equal to 18 by 55. Okay. So, this is the probability that defective item came from machine 1. Similarly, we can find the probability that the defective item has been manufactured by machine 2. Okay. So, that we can also find a probability that the defective item came from machine 2. Okay. So, we have probability that defective item machine 2. Okay. So, this will be equal to P B into P F by B divided by P A into P E by A plus P B into P F by B plus P C into P G by C. So, this is equal to P B. P B is equal to 0.35 and the defective item probability of that it produces defective item the machine 2, that is 0.03. Okay. So, 35.35 into 0.03 divided by 0.45 into 0.02 plus 0.35 into 0.03 plus 0.20 multiplied by 0.04, and this is equal to 105 divided by 275. So, we get 21 by 55, and similarly probability that defective item was manufactured by machine 3. Can be found. This is equal to P C multiplied by P G by C divided by P A into P E by A plus P B into P F by B plus P C into P G by C. So, this is equal to 0.20, okay. P C is 0.20 into P G by C is 0.04 divided by 0.45 into 0.02 plus 0.35 into 0.03 plus 0.20 multiplied by 0.04. So, this is 80 divided by 275. So, this will be 16 by 55. Okay. So, this is how we find the probabilities in this example. Now, let us say we have a talcum powder manufacturing company. A talcum powder manufacturing company had launched a new type of advertisement. The company estimated that a person who comes across the advertisement will buy their product with a probability of 0.7. Okay. So, the person who has come across the advertisement buys their product with a probability of 0.7, and that who does not see the advertisement will buy the product with a probability of 0.3. If an area of 1000 people, 70% had come across the advertisement, what is the probability that a person who buys the product had not come across the advertisement. Okay. So, what is the probability that a person who buys the product, okay, had not come across the advertisement, had come across the advertisement. So, first we find the probability that a person buys the product, okay. A person buys the product. Probability that a person buys the product. So, the company estimated that a person who comes across the advertisement will buy their product with a probability of 0.7, okay, and that who does not see the advertisement will buy the product with a probability of 0.3. 70% had come across the advertisement. So, first we assume that the 70% have seen the advertisement. So, the probability that is probability that the person has seen the advertisement is 0.7, okay, multiplied by, if he has seen the advertisement, he buys the product with a probability of 0.7, okay, plus the person has not seen the advertisement, that probability is 0.3, okay, into he buys the product with probability 0.3, okay. So, this is 0.49 plus 0.09. So, we have 0.58, okay. So, a probability that a person buys the product, okay, is 0.7 into 0.7, where 0.7 is the probability that he has seen the advertisement, and he has seen the advertisement, then he buys the product is the probability again. So, that probability is also 0.7, and then he does not see the advertisement, that probability is 0.3, and when he does not see the advertisement and he buys the product, that probability is 0.3. So, 0.7 into 0.7 is 0.49, 0.3 into 0.3 is 0.09. So, it is 0.58. Okay. Now, it is given that he buys the product, and then if he has not come across the advertisement. So, for the part A, the required probability is okay, he had not come across the advertisement, that means 0.3, 0.3, he still buys the product. Okay. So, 0.3 into 0.3 divided by 0.58. So, this will be 0.09 divided by 0.58, that is 9 by 58. Okay. And in the part B, had come across the advertisement. So, that probability is 0.7 into 0.7 divided by 0.58. So, that will be 49 by 58. Now, we discuss the probability networks, or we also call it probability tree. We can construct probability tree diagram to help us solve some probability problems. It is simply a way of representing a sequence of events. Tree diagrams are particularly useful in probability, since they record all possible outcomes in a clear and uncomplicated manner. The first event is represented by a dot. From the dot, branches are drawn to represent all possible outcomes of the event. The probability of each outcome is written on its branch. Okay. It can be used to calculate combined probabilities of two independent events as well as the two events which are not independent. For each pair of branches, the total of the probabilities adds to 1. For each pair of branches, the sum of the probabilities must be equal to 1. Now, let us consider the following schedule of a tennis tournament. In the quarterfinals, player 1 plays player 2. Okay. Whosoever is the winner, he plays player 3 in the semi-finals, and then whosoever is winner, he plays with player 4 in the finals. Okay. Now, we have to find the probability that player 1 is the champion in part A, and then we have to find the probability that player 4 is the champion. Okay. So, let us draw its probability diagram, okay, probability tree. Okay. So, this is the probability tree. One plays in the quarterfinals with the player 2. If one wins, okay, then he plays the player 3. Okay. If one wins, okay, he plays the player 4. Okay. Again, if he wins, he becomes the champion. Okay. So, player 1 plays with player 2, he wins with probability 0.70. Okay. And then he wins again, if he wins, okay, he wins with probability 0.60, and again when he plays with player 4, he wins with probability 4-0. Now, if one loses, okay, then second winner, second wins the quarter final. Okay. So, if one loses, then second plays with player 3 in the semi-finals. Now, if second loses, okay, then he loses with probability 0.5, he wins with probability 0.5. You can see the total of both the branches, probability sum of the both the probabilities is 0.70 plus 0.30 is 1, okay, for each pair of branches. So, it is 0.50 here, 0.50 now. Second player, after he wins in the semi-finals, he plays with player 4 in the final. Okay. If he wins with probability 0.20 and he then becomes the champion. Okay. Now, if second loses with the in the semi-finals, okay, if second loses in the semi-finals, then third wins. Okay. Third wins, third then plays with player 4 in the finals. Okay. If third loses, 4 becomes the champion. Okay. So, third loses means 4 becomes the champion. Now, here if the second wins, okay, then he plays with player 4. Okay. He at this point he plays with player 4. If he loses, the 4 becomes the champion. Okay. So, 4 becomes the champion. Now, here if first wins, okay, then he plays with player 2, okay, in the semi-finals. If he loses, then second wins the semi-finals, then second plays player 4, okay, second plays player 4 in the finals. Okay. If second loses, okay, then here one wins, then he plays player. If one wins, then in the quarter finals, if one wins, then he plays with the player 3. Okay. He plays with the player 3 in the semi-finals. So, here one loses means 3 wins. One loses means 3 wins. Now, here 3 wins, third player number 3 plays with player number 4 in the finals. Okay. Now, if 3 loses, 4 becomes the champion and we reach here. Okay. If third wins against the player number 4, then third becomes the champion. Okay. Here let us look at this branch. If one wins against player 2, okay, here if one wins against player 3, here one plays with player 4. Okay. If one loses, 4 wins. Okay. So, 4 becomes the champion. Okay. Now, let us find the probability that 1 is the champion. Okay. So, probability that player 1 is the champion. So, let us go to take this branch. Okay. So, this is 0.70 into 0.60 into 0.40, okay, and it is 7 6 ja 42, 42 4 ja 168. So, this is 168. Okay. So, player 1 is the champion and the probability of player 1 becoming the champion is 0.168. Now, player 4 is the champion. So, let us find this probability. Let us follow all the paths that lead to 4 becoming champion. Okay. So, first path is this one, this path, this and this. Okay. So, this path. So, along this path we have 0.70 into 0.60 into 0.60. Okay. So, we have considered this path, one wins, one loses. Okay. Now, one wins, one loses, third loses. Okay, this path. So, 0.70 we are considering this path, this path, this path, this path. So, 0.70, 0.40, 0.70, 0.70, 0.40, 0.70. Okay. So, I have considered this path. Okay, this path. Now, I have considered this path. I will now consider this path. Okay. So, 0.30 into 0.50 into 0.70. Okay. Now, you consider this path. Okay. So, 0.30, 0.50 and then 0.80. So, there are 4 paths which lead to 4 being the champion. Okay. So, the probabilities are 6 6 ja 36, 36 into 7 0.252. Okay. First one is 6 6 ja 36, 36 7 ja is 252, then 7 into 7 49, 49 into 4 196. Okay. Then we have 7 5 ja 35, 35 into 3 is 105. So, 0.105 and then we have 5 8 ja 40, 48 5 8 ja 40, 40 into 3 is 0.120. Okay. So, we have 0.252, 0.196, 0.105 and 0.120. So, we have 0.673. Okay. So, this is the answer 0.673. Okay. Now, let us go to one more question on probability networks. Swastik company and Chakra company are the only competitors for a commonly used consumer good. Presently, the market share of Swastik company is 30% and the market share of Chakra company is 70%. Swastik and Chakra both have plans to develop improvements of their products. The probability that Swastik develops its product is 0.80. Okay. If Swastik develops its product, Chakra will also develop its product with probability 0.50, in which case the market share of Swastik will be 70% with probability 0.15, 50% with probability 0.35 and 40% with probability 0.50. If Swastik develops its product and Chakra does not do so, the market share of Swastik company will be 70% with probability 0.70, 50% with probability 0.30. If Swastik does not develop its product, its market share will remain 30%. What is the probability that Swastik will have a market share of at least 50%? So, let us see, we have drawn the tree diagram here. So, start. Swastik develops its product. Okay. Swastik develops its product. The probability of Swastik developing its product is 0.80. Okay. So, this is 0.80 and Swastik does not develop its product, that probability is 0.20. Okay. When Swastik develops its product, suppose Chakra also develops. Okay. Chakra develops with probability 0.50. Okay. Chakra develops with probability 0.50. So, suppose Chakra also develops its product, then the market share of Swastik company will be 70% with probability 0.5, 50% with probability 0.35, 40% with probability 0.50. If Chakra does not develop, okay, here Chakra develops, then the probabilities of Swastik are given. If Chakra does not develop its product, the probability of Chakra not developing its product is again 0.50, then the market share of if Chakra does not develop its product, Chakra, in which case we have this, if okay, so Chakra does not if Swastik develops its product, Chakra does not do so, the market share of Swastik company will be 70% with probability 0.70, 50% with probability 0.30. So, 70% with probability 70 and 50% with probability 30. That is the market share of Swastik. Okay. And if Swastik does not develop, its market share remains 30%. So, we have this probability tree diagram. Now, let us see what we have to find. What is the probability that Swastik will have a market share of at least 50%? Okay. So, let us see which route give us the market share of Swastik as greater than or equal to 50%. Okay. So, one route is this, we move directly and reach here, it is 70%. We go this route and come here. Okay, this is 50%, and when you follow this path, it is 40%. So, we will not consider this. Here we can consider this path. This is 70%. Okay, and again this path. This is 50%. So, this path, this path, this path, and this. Okay, 4 paths leave give us the market share of Swastik as greater than or equal to 50%. So, let us first consider this path. Okay, path 1. Okay. So, the probability, required probability is 0.80 into 0.50 into 0.15. Then we again go this way, this path this way, then 0.80 into 0.50 into 0.35. Then we come this way, 0.80, 0.50, and then 0.70. Okay, 0.80, 0.50, 0.70, and then 0.80 into 0.50 into 0.30. Okay, because this is having probability 0.30. Okay. So, how much we get here? 0.80, 0.50 is common, okay, in all the 4 terms. So, we can take that as common, and then we have 0.15 plus 0.35 plus 0.70 plus 0.30. Okay. So, how much is that? This is how much? 8 5 ja 40. Okay. So, we have 0.4. Okay. This is 0.80 into 0.50, which means it is 0.4. Okay. And here how much we have? 0.15 plus 0.35 is 0.50, 0.50 plus 0.70 is we have 0.50 plus 0.70 plus 0.30. Okay. So, this is 0, 1.5. Okay. So, this is 1.5. So, we get this is 60. So, that means 0.6. So, the required probability is 0.6. So, this is how we can find the probability. You can see that these are very complex questions, but when we draw the probability tree diagram or we consider the probability network, it becomes simple to calculate the required probability. So, that is the benefit of the probability tree diagram. With this, I would like to end my lecture. Thank you very much for your attention.